Hi everyone, this is Charunla Mohan Kumar. I done a 1 month internship from Emertxe Technology. Now I am going to explain about my final project, the micro event simulation. Our team members are Gopisetti Saicharan, Gurla Bharat Kalyan, Charunla Mohan Kumar. Now next we'll discuss about this table of contents. Those are introduction to embedded C, embedded system overview, and micro-oven simulation. In that introduction to embedded C, we explain about the why C is preferred and embedded C architecture. In second one, embedded system overview. In this one, we will explain embedded system architecture and software tools used. And third one, micro-oven simulation. In this one, we'll explain about the project overview and key learnings and takeaways. Is now introduction to embedded C. Why C is preferred? Actually, C has a more efficiency and performance other than the languages. It explains more efficiency. This sample function with minimal CPU cycles, which has taken less time, which is crucial for our embedded systems. And second one is small memory footprint. Embedded devices have limited memory, and C allows fine-grained control over RAM and ROM usage. This example, these actually store into the ROM, not RAM. Now, next we'll discuss about the data types and variables in C. Now, data types in C. C provides data types to store various kinds of data. These are categorized into actually four types. First one is basic data types. In that basic data types contains integer, float, char, double. Integer stores whole numbers. Floating point, that is float, stores decimal numbers. Character, that is char, stores a single characters. Double precision floating point, that is double, that stores a large decimal values. Next one is derived data types. Array. Array is a collection of similar data types. Pointer stores memory address of another variable. Structure groups different data types under name. Union similar to structures but shares memory. Enumeration that actually represents the enum. It defines a set of named integer constants. And fourth one is void that actually it is used for the functions and does not return any value. Next, we will discuss about variables. Variable is a name assigned to a memory location that stores a value. Actually, to represent the variables, it has some rules that contains letters A to Z, digits, and underscore. It cannot start with a digit and must not be a keyword. Examples like int, float, return, and case sensitive. Now we will explain about the control statements. See, control statements manage the flow of execution in the program. Actually, these control statements have conditional statements and loops. In these conditional statements, there are actually three types. That is, if statement, else if statement, and if else statements. If statement, these works as if the condition is true, then it will execute the code. And next else if statement, these executes as if the condition is true, then it will execute the code in the if loop, and um, otherwise it will goes to the else part. Next, we will discuss about the data representations. Integer representation, it actually stored in the binary format, and the size depends on the data type and the system architecture. It can be assigned, that is signed or positive and a negative, and unsigned means only it contains only positive. And next, floating point representation. It uses IEEE 754 format with sign, exponent, and mantissa. It actually stores as float 4 bytes and double 8 bytes have different precision levels. Next, third one is the character representation. The characters are actually stored as in ASCII values, that is 1 byte or Unicode. The carries 1 byte that exists 8 bits and can store values from minus 128 to 127. Next topic is arrays and pointers. Next, these arrays actually stores multiple values of same data type, and the pointer stores memory address. Hmm. Wait. What on the structures and file handling. Structure stores multiple variables of different types, and file handling allows reading or writing data to files. While we write the data, we actually file handle can be done by reading or writing. This reading can be done by we can read the data in the code, and writing the data means it will uh, మధ్యలో ఎందుకురా గ్యాప్ వచ్చా it the data. Okay, that's all. The-
Hi everyone, this is Bharat Kalyan. Now I will say about embedded system overview. What is an embedded system? Embedded system is a hardware plus software system intended to perform a specific task is called an embedded system. Now we will see some examples of embedded system in our day-to-day life. In the given diagram, we see microwave oven, washing machine, LED TV, CCTV cameras, airplane, hard disks, and many more in which we use embedded systems in our day-to-day life. Now we will see embedded system architecture. Embedded system architecture contains a hardware unit in which the inputs are sensors and the outputs are actuators, in which the sensors use a data to hardware unit in which memory and CPU transmits and process the data and gives the required output to actuators. Now we will see some basic components of embedded system, that is LED. LED programming. LED stands as for a light emitting diode. LEDs emit light when current flows through them. In microcontroller based systems, LEDs are controlled via general purpose input output pins, which are shortly called as GPIO pins, which toggles between high and low off states. That is, LED has only two states in which light on or light off. Now we will see one other component of embedded systems. Switch programming in embedded systems is essential for user input handling, such as toggling modes, starting operations, or interacting with the microcontroller. These switches are also connected to embedded systems via GPIO pins only. There are few types of switches in embedded systems. They are push button, toggle switch, rotary switch, membrane switch. In this diagram, we see some types of switches. For example, push button contains only temporary on or off state. Toggle switch maintains its on or off state. In the same way, rotatory switch, membrane switch is also used in embedded systems. Now we will see another component called as triggering. In embedded system, triggering is mainly done as two types: level triggering, edge triggering. This triggering is used for interrupts handling time operations. First of all, level triggering. Level triggering, the signal is active as long as it stays at a particular voltage level, high or low. In the level triggering, there are again divided into two types of triggering: high level triggering, low level triggering. High level triggering occurs when the signal is high, that is 1. Low level triggering occurs when the signal is low, that is 0. Now we will see edge triggering. Triggering occurs only when a signal change states from high to low or low to high. The system responds only at the transition. Okay. Then edge triggering, rising edge triggering, low to high transition, rising edge triggering, falling edge triggering, high to low transition. In the given diagram, this is level triggering and this is edge triggering. Now we will see another component which is interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller in which an external or internal device requires the MPU to stop the processing. The MPU acknowledges the request, attends to the request, goes back to the processing where interrupted. Interrupts were divided into many types. First one is hardware interrupts, software interrupts. Hardware interrupts were also divided into non-maskable, maskable. Maskable interrupts are also divided into external, internal interrupts. In this way, interrupts were divided. And the matrix keypad. It is also one of the useful component in embedded systems. Matrix keypad is same like as our dial pad in our day-to-day mobile. In the matrix keypad, it has contains digits from 0 to 9 and some special characters which are useful to control embedded systems. A matrix keypad is a commonly used input device in embedded systems. It is used as an input device consisting of multiple rows and columns of buttons. It minimizes the number of GPIO pins required compared to individual switches. We all know that individual switches requires many GPIO pins to operate with microcontroller. But with the help of matrix keypad, we can use some only one keypad that which contains many operations and in which we can use it. And timers are the essential parts in embedded systems because time plays a crucial role in operating embedded systems. Okay, the sum of the functions of timers are delays, event counting, and periodic task execution. Now we will see types of timers. Software delays created using loops and no operation instructions, not efficient as it wastes CPU cycles. Hardware timers provided by the microcontroller for accurate timing operates independently of the CPU, can trigger interrupts when a specific time elapses. Now, this is the last part of basics of embedded system components, that is CLCD, which is abbreviated as character liquid crystal display. It is a display or it is a output device of an embedded system in which we can see the output of an embedded system or in which we can give instruction to the embedded system through matrix keypad in which the instruction is displayed. There are two types of communication modes, 8-bit mode, 4-bit mode of a CLCD.
Hi, my name is Gopisetti Saicharan and I completed my one month internship in Emertxe Technologies. Now I will discuss about project implementation. First, I will discuss about required tools for project implementation. In this project, we used over three tools, which are MPLAB XIDE, which is an integrated development environment developed by Microchip Technology. Second, we used X8 compiler, which is also a C compiler developed by Microchip Technology. Now, our third required tool is PICSIM LAB. PICSIM LAB is a graphics simulator for microcontroller based circuits. Okay. Now we will discuss in detail of each tool. MPLAB XIDE is an integrated development environment as discussed earlier. We use it for programming PIC microcontrollers and DSPIC digital signal controllers. It provides a complete toolset for writing, compiling, debugging, and simulating embedded applications. These are some key features of MPLAB XIDE, which are it supports multiple microcontrollers and also works with PIC 10, PIC 12, PIC 16, etc. It also uses GCC based compilers. which in the sense supports XE8, XE16, and XE32 compilers for different MCU families, and also used as debugger and simulator support. And our second tool is MPLAB XE8 compiler. As the name indicates, compiler, it uses for compiling into and it converts C code into machine code that runs on PIC10, PIC12, PIC16, and PIC18 series microcontrollers. These features are optimized for 8-bit PIC MCUs. In the sense it supports PIC10, PIC12, PIC16, etc. Its future is ANSI compatible, which in the sense compatible for ANSI programming. Uses for standard embedded C syntax. Another feature is its built-in peripheral libraries, which includes functions for GPIO, timers, UART, I2C, SPI, ADC, PWM, EEEPROM, etc. And our third tool is PICSIM LAB. PICSIM LAB is a graphical simulator for microcontroller-based circuits designed primarily for PIC, AVR, and ARM microcontrollers. It allows users to test embedded systems, peripheral interfacing, and microcontroller programming without requiring physical hardware. The features of PICSIM Lab are as mentioned. Supports the multiple microcontroller families for PIC, AVR, ARM Cortex. It also integrates with MPLAB X IDE, runs for hex files, compiled using XC8, XC16, XC32 compilers, and also used from virtual peripherals which are like LCDs, keypads, etc. And now we'll discuss about our main project. This is microwave oven simulation. Microwave oven simulation has three modes. They are micro mode, grill mode, and convection mode. Micro mode in the sense heats food using microwaves. Grill mode in the sense grills using heating elements. And convection mode in the sense uses fan for heating and baking. Now we will discuss each mode in detail. Micro mode. In a microwave oven simulation, the micro mode is one of the main cooking modes that uses microwave radiation to heat food. This mode is usually simulated using microcontrollers like PIC, interfaced with components such as LCD, keypad, timer, and buzzer. Sorry. Features of microbot are as follows. It uses for microwave energy to heat food, uses set times and power level using keypad, countdown timer starts when the oven is activated, and buzzer alerts when cooking is completed, door switch detection ensures safety, etc. are many features for micro mode. And our second mode is grill mode. In a microwave oven simulation, the grill mode is used for browning and crisping food by heating an electric grill element. Unlike micro mode, which uses microwave radiation, grill mode relies on a heating element to generate heat. The features of grill mode are as follows. Uses a heating element instead of microwaves. User setting grill time via keypad. Countdown timer starts when grilling begins. Buzzer alerts when grilling is done. LED represents the heating element in the simulation. And our last mode is convection mode. Convection mode in a microwave oven uses a fan and a heating element to circulate hot air, ensure even cooking. Unlike micro mode or grill mode, convection mode combines both to allow baking and roasting. The features of convection mode are as follows. Uses a heating element and a fan for uniform heat distribution. User sets time and temperature via keypad. Countdown timer starts when the convection begins. Buzzer alerts when cooking is done. LEDs simulate heating and fan operations in the simulation, etc. are some of the features of convection mode. Now we will discuss about the project outputs. For MPLAB XID output, this will be our output, which contains build successful at the output, and these are the PICSIM lab outputs for each mode, like micro mode or grill mode or convection mode. Okay, now we will discuss how this works by using our. Wait a second. Okay, now we will discuss using MPLAB XID. Yeah, as now we will open the project. One second, we will open the project. Yeah. This is our project we stored in the name as microwave oven project.x. Uh, Now, after opening the project, these are the source files and these are the source files listed, which is CLCD file, which is ISR file, which indicates the interrupt file, and this is our main file, and this is matrix keypad file, and these are timers file. Now we should build it. Yeah, as you can see, the build is successful. Now you can see each file In the sense, yeah, this is the code for each file. And this is code for interrupt file, and this is code for CLCD file, and this is code for main file, and this is code for matrix file. Okay, and this is timer file as well, and these are some linker files and other important files. And as the build is successfully completed, now we can use the same hex file in PICSIM lab. Okay, now we will go for PICSIM lab. Yeah, this is the PICSIM lab icon, and as I load early, it's just showing. Now we need to load again, and by loading hex, yeah, this is our hex file for loading in PICSIM lab. Okay, now after opening, yeah, this how it's power on. The microwave powers on. Okay, and as we discussed earlier, there are three modes that are shown above. We indicate the number as 1 for micro, and 2 for grill, and 3 for convection, and as we know, 4 for start. Uh, First, we will discuss from micro mode. For micro mode, we need to click 1, and as you can see, this power is 900 watts. Now we need to set a time. Let me set for 5 seconds because and the star and hash will show as enter, and star represents clear. Okay, let's start the timer, and you can see that a fan is running, and after the 5 seconds, the buzzer will show. Yeah, you can listen the sound as well, and it represents the timer. Okay, that's how a micro mode works. And second is grill mode. By clicking two, we can see that we need to set a time, and as same as micro mode. Let me keep again 5 seconds. Okay, let's just start the process. After 5 seconds, as same, it will. Okay, yeah, completed. Yeah, you can see how that it works. And now see our last mode, which is very important mode, convection mode. First, we need to set a temperature, and it also uses preheating time. Let me keep temperature of 10 so that it will be easy for me as well. See, there is a preheating reminder. Now I am going to skip the video. Yeah, you may see that 165 seconds has passed. Okay, this preheating is required because in convection mode preheating is necessary, and after 6 seconds the buzzer will start again. So, yeah, 4, 3, 2, 1. Yeah, now we need to set the time for convection mode. Let us keep again 5 seconds, which will be easy for us. And timer will start. And you can see the start, pause, and stop options. Yeah, that's how our microwave project works. Now we need to match them with our. Wait a second. Yeah, these are our convection mode and grill mode operations. And thanks Emertxe Technologies for providing this wonderful opportunity. Thanks Jayalakshmi ma'am and thanks Anusha ma'am for providing this internship.
Thank you.
Thank you all.